So this is building a Tellurion. And yes, Tellurion can be spelt in various different ways, so don't worry if you've seen it spelt differently. So let's start with the basics. What is a Tellurion? So perhaps many of you have already seen this sort of thing, a solar system, an orrery, which demonstrates the motion of the planets around the sun and occasionally motions of moons around planets, such as the moon around our planet Earth. A Tellurion is similar, but concentrates on how the moon goes around the Earth and how the Earth goes around the sun. So it's like a little bit of a solar system, but in a lot more detail, and it can simulate the motion of the moon and the Earth and the sun much more usefully than can a orrery, which is trying to show you the entire solar system in one go. Both of these particular objects that we can see illustrated here are manufactured, or at least distributed, by the same company, a company called Eaglemoss, which I'll come back to later. So, why build a Tellurion? Why would you want to? Well, some of us like building things, but one of the reasons for building a Tellurion is because it can be used to demonstrate, for instance, it can demonstrate night and day, it can demonstrate the changing of the seasons on Earth, it can demonstrate lunar phases, and it can demonstrate lunar eclipses and solar eclipses. So for one object, as it were, it actually has a number of different uses. So I don't necessarily say that every school should have one of these, but it is a very nice looking thing, and I thought this would be a great thing to use for outreach, to take to schools or to take to Cubs or Scouts or to take to any other evening in which you can demonstrate these various aspects of how the moon, the Earth, and how they move around the sun. So in terms of how does this particular arrangement show eclipses, before I look at the Tellurion itself, let's just remind ourselves of how eclipses occur. The moon going round the Earth in an orbit that is inclined by a few degrees, about 5 degrees or so, relative to the plane of the ecliptic. The ecliptic is this flat area here, which is the plane containing the Earth's orbit around the sun. So there's the ecliptic. But notice that because the moon's orbit is inclined, sometimes a new moon will cast a shadow that simply goes over the top of the north end of the Earth. And again, the Earth's shadow will not be cast on the full moon. So you won't get either a solar eclipse or a lunar eclipse. And similarly on this side, the new moon will cast a shadow which goes too far south of the Earth. And again, the Earth's shadow is too far south to cast a shadow on the full moon. But if the alignment of the orbit of the moon is such that these lines, and we call these lines the lines of nodes, so the moon crosses the plane of the Earth's orbit at a node. So a node is this point here or this point here. It's the point at which the moon is not only in its own orbit, it's in the plane of the Earth's orbit. And that occurs here, and it occurs at the far side here. And so when the moon is at one of these so-called nodes, then it is possible for the new moon to cast a shadow on the Earth, giving us a solar eclipse, or it's possible for the moon to go into the Earth's shadow, giving us a lunar eclipse. So what matters is how often the moon actually arrives at one of these so-called nodal points, the points at which the moon is in the same plane as the Earth's orbit. I thought it was worth doing that as an aside, just to remind you how lunar eclipses and solar eclipses actually occur. So back to the Tellurion. There are 3 different types of lunar month that are built into the mechanism of the Tellurion. The so-called synodic or synodic month, this is how long it takes the moon to go from one new moon to the next new moon, from one phase back to that same phase again. And that is dictated by this particular part of the Tellurion, this ring that the moon actually sits on. This has to rotate once every synodic month to bring the new moon back to where it should be once a month. In addition, there's a so-called draconic month, which is how long it takes the moon to go from one node back to that same node again. And that's determined by this ring here, which perhaps you can see, maybe it isn't so clear, but perhaps you can see that ring is actually tilted relative to the other parts of the Tellurion. And that's because the moon actually rests on a wheel which moves in this track, and so by tilting this track, that makes the moon go up and down as it would because of its 5-degree tilted orbit. And the length of time it takes to go from one part of that track to the same part of that track is a so-called draconic month. And one final month that's worth embedding into the Tellurion is the so-called anomalistic month. This is how long it takes to go from the moon at its closest point to the Earth back to the point which is closest to the Earth. And that is not embedded into the mechanism that we can see here. It's actually embedded in a different part of the mechanism. The moon actually goes around the Earth in an ellipse, and whenever you've got cogs and gears, it's rather tricky to make gears that are elliptical because they will not mesh at various parts, and you can find ways of making the moon move backwards and forwards as if it was in an ellipse, but in this particular Tellurian model, the moon moves on a so-called synodic ring. There's a draconic ring underneath tilted at 5 degrees, but to find out whether the moon is at its closest or at its furthest from the Earth, or somewhere in between, that's indicated by a different part of the mechanism with a little pointer down here, which tells you, for instance, if you're in a position such that the moon is in eclipse, it will tell you whether the moon is close to the Earth, in which case it might give you a total eclipse, or whether the moon is further away from the Earth towards apogee, in which case it would give you an annular eclipse if the moon is not large enough to cover the sun. So each of these months are a different length, and they all have to be built into the mechanism in order to be able to predict when do you get a lunar eclipse, when do you get a total solar eclipse, when do you get an annular solar eclipse. A synodic month is about 29.5 days, a draconic month is about 27.2 days, and an anomalistic month is about 27.5 days. Each of them are different, and they are coded into the Tellurion by the number of teeth that are in each of these gears. Each of the cogs and gears that intermesh in the Tellurion are designed such that the length of time it takes the moon to go around the Earth is that many days. The length of time it takes this orbital ring, this moon orbit that's inclined at 5 degrees, how long does it take the moon to get back to the same point in that ring? 27 and a bit days. And again, how long does it go from perigee to perigee or apogee to apogee? That's encoded in a pointer down here that tells you what type of eclipse you're going to get. So all very clever. Somebody had to sit down and work out exactly how many teeth you have in all of these gears in order to encode each of these different types of month such that you get a realistic view of how the moon moves around the Earth. So if you want to build yourself a Tellurion, how do you do it? Well, you collect all of the parts. You know how it works. Builds in weekly parts to a complete Tellurion. In other words, if this particular manufacturer decided to make these again, unfortunately, they have been made, they have been distributed. I do not believe they are currently available as a collector's item that you can build up week by week. But when they were available, the 1 week you would get a magazine and one part of the Tellurion. The next week you would get another magazine and another part of the Tellurion. Then the 3rd week, the 4th week, the 5th week, etc. And yes, it would take 52 weeks before you had all of the parts that you needed. You can start building it as soon as you have the first few magazines. Each magazine contains a few interesting articles about the moon, about the Earth, about the sun, or perhaps other parts of the solar system. And as you've seen, each magazine contains a few parts and the instructions as to how you put those together. So if you've got the patience, and if Eagle Moss decide to redistribute these again, they had a distribution, then they stopped, and then some years later they started it again, and again you could buy each of these 52 parts weekly. They then stopped, and I don't know if they intend to start it a 3rd time, in which case again you will be able to effectively sign up for weekly deliveries of the magazine and the parts. And if you do get to part number 52, Don't forget to make sure that you have that grub screw. It's not going to hold the whole thing together, but that's very easily lost. If you look inside one of the magazines, you find instructions, which I reckon are actually very good. So, for instance, it gives you a table of what you can expect from this particular part or this particular magazine or this particular stage of the construction, which particular item has which particular number and which magazine does it come with. So you can say that magazine has got a sealed bit of plastic, and if I cut it open, I'm going to find inside there's one of these gears and 3 of these screws, for instance. So it tells you exactly what you get with each magazine. It tells you how they fit together with a picture like shown on the left there, and it gives you an exploded view of everything that's put together in this particular assembly, and it tells you what it should look like once you've put all of those bits together. So the exploded view helps you get everything in the right order as well as following the instructions, and when you're finished, if it doesn't look like that, you know you've put that particular assembly together incorrectly, and you can go back and fiddle with it if you need to. So the instructions, I think, are very good. If you don't like the idea of waiting until Eaglemoss decide to reissue the entire 52 parts of the entire Build Yourself a Tellurion, the option is to find other people who've got spares. And you can go on Facebook and you find people on Facebook that have collected all of the bits and have decided not to build it. Don't ask me why, but they appear to have a full set of all the parts and all the magazines that came with it, and for one reason or another they've decided not to put them all together. Perhaps they thought it was a good idea at the time, but once they got all the bits, they didn't have the enthusiasm perhaps to actually decide to cut it all open and get all the bits laid out and start building it. And they certainly didn't decide to start building it as the first few pieces came along. So there was a Facebook advert for please come and take this off my hands sort of thing. In this particular case displayed on the kitchen counter. You can go to eBay and you find people selling parts. Sometimes somebody will sell you every single one of the 52 parts. Sometimes they'll sell you most of the parts. Sometimes they'll sell you half a dozen of the parts. Some people just sell you one part. I don't know why they sell just one. Surely they can't have actually bought one part and then stopped. It's not necessarily part number 1. They might simply sell you part number 47 or part number 23. So bear that in mind, that some people will sell you small numbers, some people will sell you a large lot, some people will sell you 10 parts for £10. And so you can start collecting the parts at a reasonable cost. I might add that if you wanted to buy the magazines, they will cost you quite a few pounds each. And therefore, after you've spent 52 lots of a few pounds, you've spent quite a few £100 if you want to buy them that way. If you can find somebody selling 10 parts for £10, then you've got a much cheaper way of getting all the bits together. But beware, some people will sell you bits and some people will say, I've got all of these bits, here they are on my floor, do you want to buy them? Bear in mind that this confused me until I realised that what this particular seller was actually selling was a few parts of an orrery, a solar system, and a few parts of a Tellurion. But not enough to build either of them. It's sort of half an orrery and half a Tellurion. This particular individual didn't know what he or she actually had, and simply wanted to get rid of all of these bits. So here I recognise that some of these parts are actually parts of a Tellurion, and I also recognise that some of these parts are actually part of an orrery. So if you are going to buy bits off eBay or Amazon or anywhere else, just be careful that you do know what you're actually buying. And as I say, sometimes you only buy a few bits from one seller and a few bits from another seller. And then you have the fun of trying to work out which bits do I need now. I've got half a dozen bits from here, and I've got a dozen bits from there, and I've got a dozen bits from there. They're not necessarily consecutive parts, so let's tick off a list, those that we've got and those that we need. And sometimes you end up buying job lots of, well, he's selling 10 for 10 quid. I don't need all 10 of them, but I do need 7 of them, and it's well worth paying £10 for 7 parts, and I'll end up with a few duplicates. so be it. So some friends and I decided to build ourselves a Tellurion by finding all the bits on Amazon or eBay or Facebook, and then we started building up the parts list. After a while, we realized that we had a fair number of duplications, just because we ended up buying more than one piece at a time, buying them a dozen at a time, or 20 at a time, or 30 pieces at a time, in order to try and build up the complete set. Because my friends and I started collecting and realized we had duplication, we paused and said, well, if we've got duplicate pieces, why don't we just build two of them? That's the way to do it, yep. So then we actually used the duplication to our advantage. And then we started trying to gather enough parts to build two Tellurions. Of course, in the process, you end up with a few triplicate parts, but let's not go there. So we decided to build two Tellurions. My friends live in Bromsgrove, and we decided to call that Tellurion South. I live a little further north, so we called that Tellurion North. This is in homage to Gemini North and Gemini South, the two telescopes, one of which is in Hawaii and the other in Chile. Okay, not quite so far apart, but rather than calling them just A and B, we decided Tellurion South, Tellurion North. Tellurion South is what I'm describing building today. Tellurion North is almost complete, but unfortunately COVID got in the way of the completion of Tellurion North. So let's have a look at Tellurion South. But before I say, just beware, if you do go down this road, some people have taken it to extremes, and once you start collecting bits of an orrery or bits of a Tellurion, some people do get carried away. But at least you know that spares are out there, because various people have got various half-built Tellurions and solar systems and will be quite prepared to sell you a few bits and pieces for a few pounds each. There's all 52 parts of Tellurion South, all ready for a build. And my friends and I decided to spend a very enjoyable weekend with various cups of tea and a little bit of alcohol, and we decided that we would take these 52 parts and build ourselves a Tellurion. So it started by putting the Earth on its axis at the end of the arm, which is ultimately going to take the Earth around the Sun. Then we added the Moon. There you can see on the gear that ultimately is going to take the Moon around in one synodic month. And then we built up the arm by including other gears, and there is the Sun in position as well. A few hints and tips. It's not a bad idea to gather a few tools together. You can, if you wish, buy a toolkit from Eagle Moss, which has everything you need. The tools and a little brush to keep it dust-free and a few other bits and pieces. But all you really need is a medium-sized crosshead screwdriver, like this one here, and a couple of Allen keys. There's a small one for some of the grub screws and a slightly larger one for some of the pieces that fit together. That's pretty much all you need. A pair of scissors is handy for cutting each of the pieces out of their plastic bubbles that come with each magazine. Long nose pliers, not a bad idea for holding some of the smaller items in place. And we found also quite useful was a mirror, because sometimes you have to look underneath to find why does this gear not quite mesh with that gear. Sometimes it's a little difficult to see, and a mirror just showing you what it's like from underneath sometimes helps. Notice also that we decided to put the Tellurion inside a shallow plastic tray. I think these are available from garden centres. And a plastic tray simply means that if you are fiddling with something in the Tellurion and a little grub screw happens to drop out and fall, then at least it's not going to go and land on the floor. Which I can assure you it never did whilst we were making this particular Tellurion. So how long did it take? Well, I think it took about 10 hours, cups of tea notwithstanding. It took something like 10 hours from the parts to opening all the parts, putting it all together and generating a Tellurion. It took then perhaps a few more hours just to fine-tune it all, because some gears didn't mesh quite right and some were just a little too loose and some were a little too tight. In some cases we had to keep readjusting the grub screws and move things just ever so slightly to try and get everything to mesh as perfectly as they ought to. by the end of the day, the gears should mesh with a tolerance of order perhaps no worse than a few tenths of a millimetre. So you could argue that yes, this is a precision engineered piece of work. And I must admit that those 10 hours were a little bit frustrating at times, but I thought they were a very enjoyable way to spend a weekend. This is the Tellurion build complete. And yes, the sun does light up. There's LEDs inside the sun, so you can, if you wish, actually demonstrate. It's not to scale, of course, the size of the moon, the size of the earth, the size of the sun, so you can't necessarily see the correct size of the shadow, but it does at least illustrate things like moon phase if you're trying to illustrate this to perhaps the younger generation. There's the Tellurion in action. It's got a speed control underneath. There's a mains adapter that provides the power, and there's a speed control so you can run it fast or slow. This is probably on something like the medium setting. And after a little while, it gets quite hypnotic. Watching the Earth rotate, watching the moon go round, identifying when the solar eclipses take place. Notice also the sun actually rotates. As far as I can tell, the sun rotates at the correct period as well. Let's just go backwards and run that again. So you see a little pointer here that tells you where the Earth arm is, where the Earth is relative to the sun. So this is calibrated in date, telling you what the date is. You can see that the Earth is tilted by 23 degrees, and the Earth's axis will stay pointing in the same direction as it goes around the sun. And down here, this pointer is pointing to either the furthest point of the moon from the Earth, where you would get a annular eclipse if the moon was in eclipse, or where the pointer is at the moment, where the moon is at its closest to the Earth, where you would get a total eclipse. And that occurs, of course, where the moon is in this position, and you can read that off. It doesn't show up too clearly in this particular view, but the eclipse ring, which is in this position, tells you when the moon is in eclipse. Obviously on this side a solar eclipse, and on this side a lunar eclipse. So they can be read off the dials when an eclipse takes place, and which particular day it is read off this indicator, which tells you where the moon is relative to the sun. So perhaps just one more time, because it is really hypnotic to watch this in action. Of course, you can work out things in days just by making a note of how long it takes to the Earth to rotate. Here we've set it to a speed of approximately one rotation of the Earth in a little more than a second, perhaps up to a couple of seconds or so. It can run a little bit faster, but then you're risking things working loose perhaps, and it can run a little bit more slowly. If we zoom in to see some of the detail in a little bit closer, you notice that this top chain is perhaps looking just a little bit loose. Maybe we needed to tweak it a little to tighten that chain. If I just run that again, you can see a reflection of the moon in this top ring. And as the reflection of the moon moves out of the way, you can see the bottom of that rod is actually the wheel that sits in the groove of the orbit that's inclined by 5 degrees that makes the moon go up and down to indicate when the moon is too high for an eclipse or too low for an eclipse. And again, it's rather hypnotic to watch not only the gears meshing, but to watch the chains that are taking the drive from the central sun axis, the drive to make the moon move, and the drive to make the Earth rotate. So that's how you build a Tellurion. You gather the 52 pieces either by doing a bit of detective work and finding eBay, Amazon, Facebook places where you can buy all of these pieces, or you wait until Eagle Moss redistribute the entire 52 set and you buy it 1 week at a time, or get your newsagent to get your weekly dose of your magazine and your next piece, and then you build it up over the course of a year. So collecting the magazines, well, that's a good way of doing it, but arguably the most expensive. And you could say that the best way of doing it is to find it as cheap as possible on eBay, but that does take a little more legwork. At the end of the day, you look at what it should look like, and I think it is very rewarding to actually, at the end of a few hours' work, actually find that the Tellurion A looks like what it's supposed to, but also works as a piece of machinery, as well as a rather nice either mantelpiece decoration, as well as a wonderful scientific instrument to which you can demonstrate day and night, seasons, lunar eclipses and solar eclipses. Having all of that in one brass instrument, I think, is very nice. So that's where you can find information. Again, I'll make these slides available to you so you don't have to worry about making a note of these web addresses. The Eagle Moss distributor on that particular web page, the top one, you can find all the information about their orrery as well as their Earth, Moon, Sun orbiter, as they call it. For whatever reason, they sometimes call it a Tellurion and sometimes call it an Earth, Moon, Sun orbiter. Back issues can be obtained from the Eagle Moss shop, though not necessarily all 52. Rather frustratingly, they might have only 40 something of the parts available for the 52-piece orrery or Tellurion. There are other web pages that have the back issues. These partwork collectibles have back issues as well, and as I've said, you can get a lot of this second-hand, still mint in the sense that all of the pieces are still sealed inside their plastic, so you're not getting a scratched version of a particular brass wheel. It's still effectively mint, but technically second-hand. You can get those from Amazon, eBay, Facebook, and other sites I'm sure are available. Thank you all for listening about how to build a Tellurion.